Welcome everybody. We've got a very interesting session today. I'll be talking about capabilities of SolidWorks SimulationXpress and SolidWorks Simulation Static module using some SolidWorks training and tutorial models. I am Volkan Susuzer from Intercad and I'm working as an application engineer in Melbourne office. Before my role in Intercad, I worked as a structural analysis engineer in aerospace industry, so I've been using finite element analysis broadly in strength justification and optimization of engineering structures for about 5 years. Let's start now. Let's have a look at today's agenda. Firstly, we will ask the important question, why do we need simulation? Then I'll briefly explain fundamentals of finite element analysis. After that, we will move on with SimulationXpress, which is included free with every seat of SolidWorks, and we'll perform a case study. Then we will be looking at static analysis module of SolidWorks simulation. We will go through a case study using this module as well. So, why would you use simulation? After designing a product, we should ask some questions to ourselves like, is my part strong enough to carry expected loads, or can I optimize material used to reduce cost of the product? To answer these kind of questions, we can perform expensive and time-consuming field tests. In other words, real physical tests. However, product development cycle is an iterative process. You design and manufacture the prototype, then you test the prototype in the field, evaluate the test results, modify the design based on the field test results, and then repeat this procedure until you have satisfactory test results. Or we can perform simulations, in other words, virtual testing. Simulations allow us to validate design virtually before committing resources to a prototype. This reduces cost, this reduces time to market, and it helps you to optimize your designs very quickly. In this slide you can see some examples of weak designs. These designs are not able to carry operating loads. So if you have a design failure, it means warranty claims. If you have over-design, it means you have reduced profit margins. So in either case, you lose money. Now, what is finite element analysis or finite element method? SolidWorks simulation uses finite element method, and it is a very reliable and pretty stable numerical technique for finding approximate solutions to many engineering problems. I will not go into depth on the theory, but basically it divides the model into many small volumes called mesh and solve elasticity equations for these little pieces simultaneously. At the end of the computations, it gives displacements, and using these displacements, the program calculates strains, stresses, and factor of safety distribution on your structure. We can get pretty good results with finite element analysis if we can construct a realistic finite element model. But as we move away from real case, the result of the finite element analysis would not be accurate. So garbage in, garbage out. During this webinar, we will use factor of safety concept frequently. So for those of you who are not familiar with this concept yet, I want to introduce it. Factor of safety is a term describing structural capacity of an engineering system. It is basically ratio of material limit stress and maximum stress observed on the system. In majority of the cases, it is convenient to use for Mrs. stress, so we're going to use for Mrs. stress throughout the session. Now we have another question. How do we interpret factor of safety? A factor of safety less than 1 indicates that the material at that location has failed. A factor of safety of 1 indicates that the material at that location is just strong enough to carry the expected load. So any increase in the load would result in failure. A factor of safety greater than 1 at a location indicates that the material at that location is safe. So factor of safety should not be less than 1 in any case. However, as number of assumptions in our study increases, we should increase this factor of safety value. Because the more the assumptions, the more the uncertainty. Now we will move on with SimulationXpress. SimulationXpress is a first-pass stress analysis tool for SolidWorks users. It helps us to judge if our part will withstand the loading it will receive under operating conditions. It has seamless interaction with SolidWorks, and it is included free with every seat of SolidWorks. It means that if you have SolidWorks, you have SolidWorks SimulationXpress. When we use SimulationXpress, we are assuming a linear static analysis. This means that there are three criteria for which the analysis is valid. Material must be linear. This means that the material behaves linearly up to its yield stress value. And this is valid for majority of engineering materials, including steel, aluminum, etc. And there must only be small displacements. Third, loads do not change with time. So we have only static analysis. If any of these are not satisfied, then the results of SimulationXpress will not be accurate. This is our first case study. We will analyze an anchor plate using SimulationXpress. Here we have a very basic assembly structure. We have a handle, and three more parts. The important point is the load path. When we apply the load to handle, it is transferred to the anchor plate through the light green part. Let's now open SolidWorks. This is our SolidWorks model. So first I'll apply material to this part. Material for this part is nylon 610. So we all know how to apply material to our parts in SolidWorks. Right click the material folder and edit material. SolidWorks has in its library has more than 150 materials, from steel, iron to woods. We will use plastics and nylon 6 to 10. Now we can run SimulationXpress. So you can go to Tools and SimulationXpress. But when I click, I have a message that says SolidWorks SimulationXpress cannot be used when SolidWorks Simulation is checked as an add-in. Uncheck Simulation in the Tools Add-ins menu, then try again. If you have SolidWorks Simulation add-in, means that you don't need SimulationXpress. So when you try to run SimulationXpress, it gave an error. So first deactivate this add-in. Okay. And now I can go to Tools and SimulationXpress. It brings up the SimulationXpress wizard, and it will help us throughout the study. First, we're going to set the options. The unit system, English or SI. I will use SI, then result location. Next. So I click Next. Now I have here SimulationXpress study tree, which is very similar to Feature Manager design tree. But in this case, you track the simulation-related features on this tree. So we'll follow these steps. First, we'll add the fixture. Obviously, we need to fix these four faces. So add fixture. In SimulationXpress, you can add the basic standard fixed geometry, which is translational and rotational fixing of the entity. This one, this one, this one, and this one. So four faces are fixed. Okay. And here is my first simulation related feature, fixed one. I don't have any other fixture in this part, so I can click Next to move on with loads. I can add a load, I can add a force or a pressure. In this case we have a force which will be applied to this face, and if we change back to right view, you can see that force is normal to the face, but if we change back to our presentation, you can see that load is applied in this direction. It's not normal to the face, so I need to say, okay, I don't want normal to face, I want force in a selected direction, and I need a reference for this plane for direction. Front plane is the best one to use. So it is in positive Z, but I want the force in negative Z direction, so just click reverse direction and specify the force value, which is 1500 newtons. Now that's good. I have loading, I have the fixtures. Click Next. Now materials section. So in SolidWorks part we have nylon 610 SolidWorks model, so it is directly transferred to your simulation study. If you want, you can use this one. If you don't want, you can change the material from here. Right click to the part symbol here, apply edit material, and you can type a different material. Okay, this is not defined. Let's pick something else. For example, let's pick a steel, ASI 304. So for your SolidWorks model, still the material is nylon 610, but for your simulation study, it is ASI 304. So when you change the material of your study, it doesn't affect your SolidWorks model, because we often make an iterative analysis. So we try different materials. So it's good. So let's change back to nylon 610. Okay, this is the Young's modulus value, this is the yield strength value. Next. And let me hide the simulation symbols. It's good. Now, the only setting we can change in SimulationXpress is mesh density. So you can use a coarse mesh for a quick and rough result, or you can use fine mesh for a little bit longer but accurate result. Or you can specify the size of your you can specify the mesh size using these two boxes. I'll use the default mesh size. Now it is being meshed. Okay, so meshing is complete. Next. Now I can run the simulation. So first, SolidWorks asks, does the part deform as you expected? Yes, it does. These faces do not move, and the maximum displacement is seen around here. So this is the first point that you can check if everything is going okay. So yes, it deformed as I expected. Now we have different plot options for Mises stress, displacement, and factor of safety. As a rule of thumb, we first check displacements. So maximum displacement is around 0.12 millimeters here, and minimum displacement is around practically 0, 10 to the minus power 30, 10 to the power minus 30, which is practically 0. Okay, now we can check for Mises stress distribution. Maximum stress is around this hole, which is 20 megapascals. But the yield strength of the material is around 140 megapascals, means that part is almost 7 times stronger than it has to be, which is good. But it may be an over design as well. Depends on how critical this part is. But in this project, the factor of safety value that I'm after is 3. So I want the software to show me where the factor of safety is below 3. Okay, and since the minimum factor of safety is around 6.7, we don't have any red regions, means that part is safe. But let's change this value. Let's change this value to, let's say, 10, just to see the effect of it. So I want now the software to show me the factor of safety values below 10 with the red color. Now you can see that it's pretty the failing regions are pretty obvious for factor of safety of 10. Let's change that to 3. That's good. Now I'm done with viewing results. Now I have two options. I can generate report, or I can generate e-drawings file, or if you don't want to do this, you can click next. But I'll show you how you can generate reports, which will save you a lot of time. Generate report, description, anchor plate, stress, static stress analysis. This is conclusion. Part is strong enough for factor safety of 3. It's good. Name, company. So when I click generate, it will create the stress report for me, and it will take about 10 or 15 seconds, and it grabs all the plots, mesh information, loading information, the element size, and the plots for maximum stress, maximum displacement values. So it's pretty awesome. 80%. We need a couple of more seconds. It's done. Here is my report. So it contains all the information regarding your simulation. So this is how you can use SolidWorks SimulationXpress to assess the performance of your parts in SolidWorks Simulation, and as I mentioned before, it's included free in every seat of SolidWorks. Means that if you have SolidWorks, you have SolidWorks SimulationXpress and use it. Now we will move on with SolidWorks Simulation static module. Static analysis module is an excellent design analysis tool for parts and assemblies. It helps us to judge if our part or assembly will withstand the loading it will receive under operating conditions. And it has seamless interaction with SolidWorks, and it's included in SolidWorks Premium. Let's see its capabilities. If you have simulation static module, you can perform part analysis, assembly analysis, connector analysis, and you can run design studies. So SimulationXpress was just a test of static modules. But using static module, you can have much more realistic modeling for your parts or assemblies. Again, we have the same assumptions, so I'll not go through these assumptions again, but we can run linear static analysis. So this is the assembly that we're going to analyze, pliers assembly. The assembly is composed of two arms, a center link, a clamp, and a plate. We will apply 180 newtons from this handle from here and here, and we are not interested in the results of this plate, so we will not going to include this in the analysis. Instead of that, we will use a boundary condition on the clamp and the lower arm to simulate it. Now let's open the model. This is the pliers model. We have two different configurations. Default configuration, which has all the parts of the assembly, which includes all the parts, and we have for analysis, and here we have only the parts that we need in its analysis. Since we have time limitation, I will not create a study from scratch, but let me show you first how you can create a new study. You can go Simulation tab, Study Advisor, New Study, and you pick a static study here. Now, before this session, I created the study and run it. It's here, by script analysis. It is, again, it has a simulation study tree to track the simulation related features, and it's very similar to the SimulationXpress study tree, but the only difference, we have two differences actually. We have parts folder here, since we're analyzing our assembly, and we have connections folder. Actually three, we have a mesh folder here as well. Now first thing to do is applying materials. So if materials are defined in SolidWorks model, they are directly transferred to the simulation study tree. So this is identical to SimulationXpress. The idea is identical. Again, you can override material here, but as I mentioned, the difference is you have more than one part, so you can apply material to single part, or you can say, okay, I want to apply carbon steel to all of the parts in this assembly. Second step is defining the fixtures. I have here fixture is defined as fixed 1. In order to simulate the plate, I've fixed this face and this face translationally. So fixed geometry, this one and this one. We used a very similar, we used actually identical fixing with simulation when compared to SimulationXpress. is fixed geometry. We are using fixed geometry, but in simulation static module you can use roller slider, fixed hinge. You have advanced settings, advanced fixtures. You can define all sort of symmetry. And if you're not sure what to use as a fixture, you can use Fixture Advisor. It helps you to pick the most appropriate fixture available in SolidWorks Simulation. Okay, let's close this one. Third step is external loads, definition of external load. In SolidWorks Simulation we have these different options: force, torque, pressure, gravity, and all the way up to thermal effects. And if you're not sure what to use, now again you can use External Loads Advisor. Here our loads are two different features, one this phase, one this phase, the other one is this phase, 180 newtons. The idea is identical to SimulationXpress study, so I'm not going to explain this again. But we have two forces, 180 newtons in negative y direction, this phase, 180 newtons in positive y direction applied to this phase. And 1, 2, 3, first step, third step. Now we're in the fourth step, which is definition of connections and contacts. In this assembly, I have a spring which is not physically modeled, so I'll show you how you can define this kind of connectors. But let's switch back to exploded state, which will make it easy to understand. Yeah. Now in my assembly, actually I have a spring between this location and this location, but I don't want to model the spring. I don't want to mesh it. I want to save time because I'm not interested in the stress results of on the spring. Instead of that, I'll use a spring connector. If you use this pull down menu, you can see different sort of different type of connectors in SolidWorks. What you need to do is you just click spring. You select the type of spring, compression extension or compression only or extension only. You pick the locations. So if I actually open the predefined spring, it will help more. Yeah. So between this vertex here and this vertex, then stiffness values, and if you have pretension, you can apply that pretension. So the other important thing is contacts. In SolidWorks Simulation we have 5 different contact types: no penetration, bonded, allow penetration, shrink fit, and virtual wall. And using these 5 different contacts you can model almost any physical contact. And let's change back to our slideshow. I'll explain bonded contact and no penetration a bit more because these are the most frequent used contact types. In bonded contact, the software bonds 2 different parts. So these entities may be touching or be within a small distance from each other. The software enforces a bonding set regardless of the existing tolerance between the selected parts. So they can't move away or interfere, just like using a superglue or a weld. Whereas in no penetration contact, the software prevents interference between 2 parts but allows gaps to form. Computational wise, this is the most demanding one, but it gives excellent results. Using these two contact types, actually these contact types will be the ones that you'll use frequently. Okay, here I have an example, not an example, but a predefined contact. And it's better if I collapse the assembly and have a sectional view, but and first section direction. That's good. Yeah. Here I have a contact between this face and the edge here. So how you can define the contact? Go to contact set and select the type of the contact that you want to use, but it's previously defined. So here, edit definition, we pick the edge on the center link, then face on the script. Now it's done. The next thing to do is defining the creating the mesh. Since I meshed this study before the session and run study, I'll not show the meshing on this specific study. Instead of that, I'll define a new study. So in order to mesh to your study, you right-click the mesh folder and you click Create Mesh. We have different options, but this is similar to SimulationXpress. The difference is we have two different meshers, two different mesh tools. One is standard mesh, the other one is curvature-based mesh. Using these two tools, you can discretize, you can mesh almost any geometry, any actually practical geometry. So you can use inches or millimeters, so you can specify the unit of your mesh. For quick solutions, you can have draft quality mesh if you're doing an iterative study, and you can use draft quality mesh throughout the iterations. And once you are sure that you have a reasonable model, you have a reasonable result, then you can run the final one with the high quality mesh. Okay, now let's switch back to our original study. Let's check the results. First rule of thumb, we'll check the displacement results. The maximum displacement is around 2.54 millimeters, and it's seen around here. Looks reasonable, but it's good to have an animation to see what's going on. It's pretty reasonable. This is certainly what we expected. Okay, now let's check stress values. So this is a plot, and this is a stress plot, and the maximum and minimum values on the plot is set to 0. The minimum one is set to 0, and maximum one is set to 248 megapascals, which is the yield strength. This makes it pretty easy to understand what's going on. So any color, any region having color red is failing. So I have a lot of failure region here. I have red colors here. Also the screw. So looks like the design is not strong enough to carry the expected load. But for better understanding, let's check factor of safety plot. This plot shows the factor of the areas having factor of safety below 1 with red color. So see, I have a lot of failing regions. Complete failure and on screw means that this design is not strong enough to carry the expected load. But sometimes this factor of safety plot is showing the areas with red color, showing the areas having factor of safety below 1 with red color, but you may want to set a different factor of safety value, for example again 3, let's say. Edit definition, Okay, show me using foam missile stress, yield strength. That's good. I want to see areas below factor of safety of 3. I wouldn't use these pliers. Okay, so this is how you can use simulation static module to assess the performance of your assemblies. Now, let's turn back to our slideshow. Now, in a few seconds, I want to introduce you SolidWorks Simulation product family. So, SolidWorks Premium includes the static analysis module that I've shown you, and also the motion kinematics. Simulation Professional, the first upgrade, you can perform frequency analysis, buckling analysis, thermal analysis, drop test, fatigue analysis, optimization analysis, and pressure vessel analysis. And if you go one step further, you can run static and dynamic nonlinear analysis, harmonic analysis, time history analysis, and random vibration analysis. And we have a separate package called Flow Simulation. And using this one, you can perform a variety of virtual tests for fluid flow problems, internal or external flow problems. This is the end of the session, and I hope you enjoyed it. If you have a question regarding this session, please do not hesitate to send me an email. You can see my email on the screen now, volkan.susuzer@intercad.com.au, my name surname@intercad.com.au, and you can also visit Intercad website, which is www.intercad.com.au for more videos. Thank you.